Good day, students. Welcome to math.serve.com, where we don't just solve, we teach. In this clip, we're going to be going over how to find the slope of tangent lines, equations of tangent lines, and how to carry out linear approximations of functions using the tangent line. All right, so instructions for this question is as follows. For the given equation and point, we're to find the following. We're to find the slope of the tangent line at the point, equation of the tangent line to the point, and the approximation of the function at 0.5. Okay, so let's say for this example, the function under consideration is f of x equals cosine to the third power of 4x. And the point is that when x is equal to pi over 8. Okay, let's start with the first part, A. We're to find the slope of the tangent line. Now, when you're dealing with tangent lines, there's a formula you want to keep in mind to help you with the problem solving process. Formula. The equation of the tangent line is basically y minus y1 equals mx minus x1. The point slope form of the equation of a line that you learned in algebra 1, you're using the same equation here, okay? So you have this equation where the slope m is equal to y prime, the derivative evaluated at x1, okay? And in order to find y prime of x1, you can break it out into two parts. First of all, you find the derivative y prime of x, and then you evaluate the derivative at the specified x value. You evaluate y prime of x1. Okay, so in the A part of this question, we have to find the slope of the tangent line. Well, m is the slope of the tangent line. Okay, so let's go ahead and carry out the problem solving process. You can clearly see that in order to find m, we need y prime, the derivative, and x1. Okay, so let's write it down. M is equal to y prime of x1. Okay, first thing we want to do is we want to find what y prime is. We know that x1 is a given x coordinate, so x1 is pi over 8. So let's find y prime. Okay, now to do that, we have the function f of x equals cosine to the third of 4x. Now, when you're dealing with powers of trig functions, you always want to rewrite it in a way that shows the appropriate composition of the functions, okay? So this is a standard notation, but when you want to carry out the differentiation of this, you have to rewrite, okay? So let's go ahead and rewrite this function. If I rewrite this function, I'm going to have f of x equals cosine of 4x raised to the what? To the third power. So you can clearly see that the cubic is the outermost function, followed by the cosine and then the linear function 4x. Okay? So to carry out the differentiation of this function, we're going to be using the chain rule. Remember, the chain rule is what you use to differentiate composite functions, as is the case here. So we have three functions, so I'm going to write this as f of g of h of x. So that's that's basically the nesting of our three functions. So that's going to be parenthesis cosine of 4x. I'm color coding it so you can see the different functions that are composed with one another to give the given function. Okay, so FGH, let's go ahead and break them up. So f of x is what? The cubic function x to the third. G of x is the middle function, which is the trig function cosine x. And h of x is the innermost function, which is 4x. Okay. Now, how do you differentiate the composition of three functions? Let's write down the formula here for the chain rule involving three functions. So if you compute in f of g of h of x, well, let's group that. We have one, yes, prime. This is equal to the derivative of the outermost function evaluated at the composition of the two inner functions times the derivative of the inner function derivative of the middle function evaluated at the inner times the derivative of the inner function. Okay, this is called the outside inside rule. You work your way from the outermost function all the way to the innermost function, holding the inner function fixed as you differentiate into respective outer functions. Okay, so in this problem, we need f prime, g prime, and h prime, and they will carry out our composition. So f prime of x, if you apply the power rule, is, let's see, what is f prime of x? It is 3x to the second power. G prime of x is, the derivative of cosine is negative sine x. And then the derivative of the innermost function, h prime of x, is equal to 4. All right, now we're going to compose using this formula here. So our derivative y prime or f prime of x is the derivative of the outermost function. You plug in g of h of x. So 3 parentheses, g of h of x is cosine of 4x. So cosine of 4x squared times g prime of h of x. So you take this derivative of the middle function, and then you plug in the innermost function, which is 4x, times h prime of x, which is 4 right here. Okay. Now, let's rewrite it, make it look pretty. So we're going to have the derivative f prime of x is equal to 12 cosine square of 4x. Oh, there's a minus here, so put the minus out there, minus sine of 4x. Okay, so what we just found is y prime, f is equal to y. So y prime of x is negative 12 cosine square of 4x, sine 4x. Okay, now part 2, remember in our formula, part 1 in finding the slope of the tangent line is to find the derivative of the function. After differentiation, then you evaluate the derivative at the specified x value, okay? So part 2, let me see, did I call it A or B? I called it A. Okay, so part B, we're going to evaluate y prime of, I think it was pi over 8, y prime of pi over 8, okay? That was our x1 value, okay? So y prime of pi over 8, which is y prime of x1. So we already have y prime here. So y prime of pi over 8 just involves substituting pi over 8 for all the x's in this equation. So we have negative 12 cosine square 4 times pi over 8 sine 4 times pi over 8. Okay, now let's simplify that. We end up with negative 12. Now cosine square, I can rewrite it as cosine. And then 4 pi over 8 reduces to pi over 2 cosine pi over 2 quantity square, okay? Sine, and then this reduces to pi over 2 also, pi over 2. Okay, so what is sine pi over 2 and cosine pi over 2? Let's sketch our graphs real quick to help us do it, or you can use your unit circle. So we know where how cosine behaves. So cosine, nice periodic function, looks something like this. That's half a period. 3/2 of a period, and there goes your complete period. So this is pi over 2 right here. So this graph shows us that cosine pi over 2 is 0. Okay, that's the y coordinate of this point. sine of pi over 2, we need that to evaluate this portion right here. So let's draw our sine function. Looks like the S's. So we have a center, top, center, bottom, back to the center. Okay, so there goes your sine function. Whenever you're working with angles involving the axis, multiples of pi over 2, the graphs normally do a perfect job in helping you out with that. Okay, so pi over 2 here, we see that based on this graph, sine of pi over 2 is 1. Okay, so let's plug in those values. We have negative 12. Cosine pi over 2 is 0. 0 squared, sine pi over 2 is 1. We multiply this whole product out to get 0. Okay, so slope of the tangent line, which is basically m evaluated at x equals pi over 8. Our answer is 0. We have a horizontal line here. All right, the next part, we have to find the equation of the tangent line. Okay, so for equation of the tangent line, we're going to be using the formula, equation of the tangent line that we specified earlier. And the formula is y minus y1 equals m x minus x1. Okay, we already know that the x1 is pi over 8. But what is y1? Y1 is simply y evaluated at x1. Okay, so all we are doing here is taking the y function. Let's rewrite it on the side right here. The y function was cosine 4x raised to the third power. We're going to just plug in pi over 8 for x in this equation, and that will tell us what y1 is. Okay, so y evaluated at x1 is basically y of pi over 8, x1 value, which is cosine 4 times pi over 8 raised to the third power. This is equal to cosine of pi over 2 raised to the third power, because 8 goes here 1, 8 goes here, 4 goes here 1, 8 goes here twice, 4 goes into 8 2 times, raising all that to the third power. So cosine of pi over 2, we already computed what that is. Cosine of pi over 2, if you've forgotten, you can look at our graph, it's 0. Okay, so cosine of pi over 2 is 0 raised to the third power, which is equal to 0. Okay, so it looks like we have everything that we need. X1 is pi over 8, Y1 is 0, and M evaluated at X1 is 0. Okay, if we put everything into the equation of the line, point slope form, y minus y1 equals m x minus x1. All right, if you simplify this, you end up with y equals 0 as the equation of our tangent line. Okay, now let's finish it up. The last part, we have to use this to approximate y of something, I don't remember, f of 0.5. Okay, so for the C part, we're going to approximate f of 0.05. 0.05 is close to pi over 8, which is approximately 0.39. So part C, y or f of 0.05, the same thing, is approximately what you're going to use using this tangent line right here. Okay, so y 0.05 is simply what you get when you input 0.05 into this equation of the tangent line that we have right here. All right, let's just make a real switch in notation here just to separate the two functions. So the problem asks us to find, f of 0.05. Okay, so what we're going to use to find f of 0.05, we're going to approximate it using the tangent line. Okay, y evaluated at 0.5. So thus, equation y equals 0 is independent of the input, so our answer is equal to 0. Okay, so if you want to approximate the output of this function at 0.5, I don't know why I put 0.05 there. At 0.5, you can simply use the tangent line as your replacement function, and you get an answer. Remember, this is an approximation, it's not the exact value.